Okay, so LeetCode 329, longest increasing path in a matrix. This has been marked hard on LeetCode, but after the end of this video, you will know that this is not a hard question. You will rate this as medium question. It has been recently asked in many companies, and the pattern this question is following is DF plus caching. For solving this question, you must be clear with the idea of recursion and the idea of memoization. Let me explain this problem very quickly. So we have to find the longest increasing path, and the way we have to explore this path is we can move from any cell up, right, down and left, and one more constraint which is given is that the next cell which we are moving should have value greater than the previous cell. So we're explaining this thing. If you see here, when we are exploring the paths from 1, we can go to 6 and 2. From 2 we can go to 6, and from 6 we can go to 9. If you see 9, we cannot go to 9 because 9 is not greater than 9. Okay, so in this way we have to find the longest path. The naive idea is to run a DFS for every single cell. At each cell, explore all 4 neighbors. If a neighbor is strictly greater, go there and keep the track of the path length. That will give you the right answer. But the problem with this approach will be you will be recalculating same paths again and again. For example, if you consider this 6, if somehow in the first path you reach here, you will be calculating all the paths from this 6, and in another path you are coming to this cell once again you will do the computation which will be done for this 6. So this is not a good solution. If you consider a longer grid, recalculating things again and again will just add up to the time complexity, and the time complexity might reach an exponential. So how to solve this? The simple solution is cache things. So here's the intuition behind solving this problem. The longest increasing path starting at any cell is always the same. It doesn't change based on how you get there. It only depends on the values around it. So once you compute the longest increasing path, store it in somewhere. So we will create a memo array where we will store the longest increasing path at that particular cell. So by this way, we are just caching the things, and we will avoid the recomputation. So let's try run this example. Let's say we start our DFS exploration at 2, 1. So from 2, 1 we can go to 2, 0, 3, 1, 2, 2 and 1, 1. But the cells which are allowing us the exploration, which are following that condition of strictly greater, are 1, 1 and 2, 0. Let's say we go to 2, 0. From 2, 0 we can go to 1, 0. 1, 0 we can go to 0, 0. If you see at 0, 0, there's no further exploration can be done. So it will just return a 1. If you can see here also, it can just return a 1. Then 1, 1 will return itself the 1 it have and the previous value. So it will return a 2. Then the 2, 0 will return a 3, and finally this 1 will have a 1 plus 3. So at the end, this will have a 4. Similarly, you can explore this cells also. It will just give a value of 3, and at the end we have to find the max. So max we have calculated 4. So this will be written. Let's go to the code. Once we are declaring the directions array, then we have just declared a memoization array here. So whenever a path is being calculated, it will be stored in this memo array, and the work of this for loops are just to go at every cell and calculate the maximum path at that cell using this DFS method. So in this DFS method, what we are doing, we are just checking if the memoization array is already filled. If it's already filled, just return things accordingly, and if it's not, just what we are doing is we are exploring the paths. We are just checking the next element to be explored. If it's within the boundary and strictly greater, we are finding the path at that next element and adding a 1 from this the current element. Accordingly, we will find the max for that for this particular cell, and at the end we will just store in this memo array. So iteration for all the cells will be done, and things at the last the maximum will be stored in this max path, and we are returning this max path at the end. Okay, so the time complexity is order of m cross n. Each cell is been calculated only once. After that, it's just a cache lookup. The space complexity will be order of m cross n for the memoization array we have taken, and in the worst case, if the longest path contains the entire grid, then the recursion stack will come into picture, and in that case the order of m cross n will be added from the recursion stack space. In an interview setting, the interview will ask a follow-up question that what if we are not calculating for strictly greater element, then what will happen? So if we use the current approach, then a cycle will be created, like 1 will be able to go to 1 also, and this will be able to go to backwards to 1. So this will create a cycle. In that case, only the memoization will not help. We will have to create a visited array. So a visited array will just store like what elements have been visited. Then it will not backtrack to the same elements. Okay, so the takeaway from this problem is, when you say a longest path in the grid types of problem, think about DFS. If there is a subproblem repetition types of problem, think about memoization. And when we are not asking strictly increasing in the same problem, use a visited array that will solve that particular. So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD, or GenAI, please follow along. The code will be given in the description. Thanks.